I am Tanya Janca, and I want to give you some tips to create more secure Python. So let's go. So what are we going to talk about today? Writing better Python. Because if you make an app that is fast and beautiful, but wildly insecure, it's still not extremely high quality app, right? We're going to talk about what to do and what not to do. And bonus, a bunch of free tools. And so now let's get really serious with a meme. Oh, wait, no, not the sticker meme, wrong meme. Yes, that's what I meant to do. Definitely wasn't making jokes about stickers. Um, Development and security, holding hands, not wrestling for the future of software development. So you're like, who is this person? So the mandatory about me slide, I am Tanya Janca. I'm also known as She Hacks Purple, and I give secure coding training for a living. I wrote 2 books, Alice and Bob Learn Secure Coding and Application Security. I've been in tech for a really long time. My first job was in 1997, so it's been a while. I have started some things, so some companies, some open source projects, some nonprofits. I am an advisor to 2 startups, Smithy and Catalyst, and I'm a board member of the Forte Group, and I am also one of the members of the OWASP Top 10 team, which we just released last week, and I write for Stack Overflow. So I do a lot of stuff, and hopefully of all of this, you think, she seems tolerable. I will put up with this for slightly longer. We do this slide to try to impress you, so hopefully you're like, she doesn't seem too bad. So more importantly, Python. You're at a Python conference because probably you think Python's awesome, and I have to say I agree. It's wildly, wildly popular for a reason, especially amongst data scientists. And I want all of you to make more secure Python so that all of us benefit. Our users, our security team, our dev team, everyone. Everyone benefits when we have more secure code, except criminals. Okay, so why does secure code matter? Very briefly, in case you missed the memo, people care now. Consumers care about security. They ask about it. Your org could go out of business if you have a major breach. Plausible deniability is no longer acceptable. We need to build and maintain user trust. We need to meet compliance standards or laws or legislation. We need to protect our users' data. We want to avoid business disruption. We do all of these things by making sure the software we use is tough, rugged, and safe. And that means it's secure. And so hopefully you're on board with that because you agreed to be in my talk, and hopefully you're not just going to click off and go watch a bunch of cat videos now. So let's talk about secure Python. Let's go over some tips because we have a couple more minutes together. So 1, let's use version 3, not version 2. Come on, we know this. If you find a security bug in Python and you are sure it is a real bug, so it could be in PyPy, CPython, pip, report it. Report it to security at python.org. But be sure, like, test it. So these are busy folks. They have a lot of things to do. We want to make sure it's a bug and make sure it's reproducible and give them as much information as you can and then report it. We security nerds really appreciate that. Update often. This goes for all languages and frameworks. And so when I say update, I mean, so, you're programming, you're building a new feature or whatever. In dev, like on your system, you do an update, you make sure everything's good. You then pin that version and promote it up all the way. I don't want it to get updated again to a slightly different version when you're in QA or like when you're in staging and then like this different version goes into prod than the one you tested. We don't want that. But every time we're doing a release of some sort, and by that I mean like a new feature or something, if you have time, please update to the latest version that is supported and test it and make sure it's good. We want to make sure we know what we're shipping though, right? So when we're thinking about our virtual environment, we could add pip freeze. And so that means we ensure the modules that we're shipping are what we think we're shipping, which is extremely important. We don't want to have our local modules interfering with or changing our project modules. And of course, we want to make sure what we're using doesn't have known vulnerabilities in it or the way we're using it is not unsafe. And I could talk about that for a long time. So like, let's say you have a library that you're using that's awesome. There's a known vulnerability in it. There are tools now, like more advanced software supply chain, usually called software composition analysis tools, that hopefully, so some of them can do this and some of them can't, but they can do reachability to see if there is a path from within your code into the library to where the vulnerability is to see if your code could actually ever reach that. And if it can't reach that, often you're okay. But anyway, those are shades of minutia, and I'm just going to keep going because I have limited time. Import the packages that you intend to. So if you can use absolute or explicit import to make sure you get exactly what you want, we do not want to leave this to chance. We want to be very specific. If you could avoid f strings and str.format to manipulate strings, basically, how about this? Let me back up. So when taking user input for use as a string in your code, we want to be careful. And ideally, we could use the template class from the string module rather than other functions for the string manipulation, which is known to be safer. So if we could avoid using fstring and str.format or anything else that is not known to be safe, that would be better. And so the template class is safer. Deserialization, which it applies to Python too. So any language that allows for serialization of an object, therefore allows for deserialization. And if you do it incorrectly, that could lead to really terrible outcomes. And so we do not want to accept a serialized object from an untrusted source. So I could talk about that at length, but I was told I had only so much time, and so I have to continue. But if you want to look up more about this, look up insecure deserialization and then either Janca or look up a WASP, and you'll find lots of content on that. We want to check our dependencies to make sure that they're safe, that they're supported, that they're in relatively good shape. And so we could use a tool like pipe env check or safety. There are some other ones out there as well. Or you could use a software composition analysis tool. Those generally cost money, where the first two I offered are free. But basically, these check that the third-party components we're using are safe, or if we're lucky, that the way we're using it is safe. You should check out Bandit. It's a Python-specific free static analysis tool. So SAST, static application security testing tool, but basically it analyzes the code you wrote rather than the libraries, and Bandit's just made for Python. Ideally, if we're gonna, we should keep certifi up to date. I know I pronounced that strangely. I don't know how to say that word, but certifi, it's used by the request library to validate that the certificates that we're accepting are on the up and up. And so, like, basically, by keeping it up to date, that means it's checking the most recent certificates and it has the complete list. We want to keep our secrets safe. And Python is the only language where an environment variable is still pretty safe, but I would prefer you put it in a secret management tool. That's the safest place. And if you can, use a secret scanner to scan all your code to see if there's a secret maybe you missed and it's in your code and it should be in your secret management tool. That is the safest place to keep it. Ideally, we would use a linter. So a linter helps us with code quality, and it helps us track technical debt and all sorts of other things. Linters help us make higher quality code. And if we're going to write better code and keep track of our code better and perform better maintenance, that's usually more secure code. But if you could also use a static analysis tool, then you'll get even better results. So some linters include PEP8, PyLint, or Flake8. There are more. Those are just, the most popular ones. If we can increase code quality and readability, all of this helps with security and maintainability, and all of that is win. We want to use the latest version, the latest supported version of Python, not the preloaded default POSIX version, because that's often out of date. And we want to be up to date whenever possible. This is pretty important. And so if you can try to use the latest version, that would be excellent. There be dragons, dangerous functions that we should hopefully not use. Okay, first, in Python 2, we should avoid the input function and instead use raw input. Input is okay, that function's okay for version 3, right? And so this assumes that you're working on a legacy app and you aren't able to update to Python 3 for business reasons. There's not money to do that. There's not time. You've been told not to for a business reason that's legit, not because we're choosing to use Python for new development. Um, Please don't use YAML.load if you're using PyYAML. So that is the default loader. Um, Instead, if we use YAML.safe_load, that's a lot safer. So basically the default lets you load arbitrary Python code. And that is a potential vector for attack called a remote code execution, which from an AppSec nerd point of view is the end of the world. We don't want that. And so don't use YAML.load, use YAML.safe_load. We don't want to use shell equals true. So we don't want like sub-processes that use that and then feed Python code into it that's from the user, like feed it any sort of user input. Like basically we're saying open a shell and execute this thing inside. We should never put a variable in there because guess what's in that variable? Something from the user usually, or something the user could have edited. Like maybe we got it from an API. Do we trust this API? Maybe we got it from the database. Was that stuff like that when it got put in the database? Are we sure that it was safe? Who put it in the database? Where'd it come from? This is really obviously a bad idea. We should not do it. Um, Use explicit to import packages. So we never want to use the implicit path. We want to use explicit. Implicit's no longer allowed in Python 3. So again, this assumes you're doing some legacy work because we want to avoid getting the wrong package, right? We want to make sure we're getting the package we think of. Right now, malicious actors are attacking our supply chains all the time and attacking legit packages, attacking maintainers, all sorts of things. And so whatever we can do to make sure we are getting the exact right version that we think we are is good. We would like to not pin our libraries to our requirement.text. So yes and no. So when we're using libraries, we don't want to pin the version, like we want to update to the latest version and then pin and then go to different environments, but we don't want to just keep it pinned all the time. We need to intentionally update, right? And so quite often, like if people add it in the requirements.txt, what they do is it's just like that forever. And it's very easy to just miss that and have it be in the requirements.txt for an extended period of time. We have like this old, vulnerable, outdated version of something when we want something new and fresh. Okay, so the following functions, we should not give it user input because just to be clear, input from the user, we should treat it as radioactive. We should assume that there's potential danger in anything that is from the user or that could have been touched by the user. So if you have something in a hidden field, guess what? The user could have touched that. If there's something in the URL parameters, yeah, maybe you didn't invite them to update that, but you better believe it that someone's going to. People always want to touch things they shouldn't. And so anything that could have been changed by the user or we know is from the user, do not add to eval exec compile. This is just a recipe for injection, right? Like you give it to them and then they perform system actions and execute code. They should never be fed user input ever. This is, again, a recipe for remote code execution. This is terrifying. We do not want this. Okay, now get ready to take a screenshot. Here are a whole bunch of free Python tools that I suggest you check out. Bandit, secure.py, Pipe check. How do you say that? Safety, PEP 8, Pylint, Flake 8, PyT, and Yosei. These are free tools that are specifically to help you write more secure Python, and we should check them out. And you probably hear my accent when I'm speaking because this is a UK, like European conference, so you're hearing my Canadian accent. Safety's Canadian. They're actually neighbors of mine. They live quite close to me and they're really nice guys and they really want you to write more secure Python. Okay, and have more secure dependencies specifically. And now more stuff. So this is a list of secure coding best practices from my first book, Alice and Bob Learn Application Security. My second book's like a lot. I have a lot more, but this is a short list. And I don't expect you to know all of this right now, but I just wanted to give more stuff in this presentation because Python is not crappy. So there was way less to say of what to do in Python compared to like Java, which will give me content for days. So we want to validate all of our inputs. We want to perform output encoding. We want to use parameterized queries. We want to ideally not write our own authentication and authorization. We want to buy a system that does it for us perfectly every time. Ideally, again, we buy a system to manage identity and session management. Doing that manually is really hard. We should use security headers like content security policy. We should not cache sensitive page data. All sensitive data that we're going to send back and forth, ideally, like for instance, our session cookie, like it should go in a cookie. So our session ID, like our token, when we pass it back and forth, if we could put it in a secure cookie, that would be great. If we're going to let people upload files, we need to be really safe. That's quite dangerous. I have a million things to say on that. We need to perform proper error handling. So errors need to be caught, handled, logged, and if appropriate, alerted upon. We should not, like I said earlier, put sensitive data in the URL parameters or any hidden fields because that's not actually a safe place. It's not very hidden. We should only go over the internet on HTTPS. HTTP is over. We should let users cut and paste into the password field. Old, misguided advice from security people from a long time ago said not to do that. Please let your users do that. We should use a secret management tool and follow secret management best practices. Oh yeah, I said, oh yes. And if we're going to store user passwords, we want to salt it and then hash it before we store it. You can pepper it too. I'm not making that up. It's a cryptography thing, but I just salt and hashing is enough for most situations. And we want to work really hard to keep our programming languages, our frameworks up to date and our dependencies up to date, which is easier said than done, I know. But maybe take a screenshot of this if you want. And I have some more gifts coming up. But first, a conclusion. We learned a few things, like not to use Python 2 for any new development. We talked about insecure functions that we should avoid, better alternatives, so better options, more safe, how to ensure safer packages, and a lot of free tools. And we talked briefly about why secure code matters, which I hope you already knew. And so I have a few resources for you. So if you are Canadian, please consider signing my petition. I realize this is a European conference, so there's not going to be that many of you. But if you're watching this over the internet, you could sign my petition about how I want Canada to be more safe. I wrote some books, and me and my mom think they're pretty good, and we're obviously not super biased about it. But you could also just read the reviews on Amazon and see that other people that aren't my mom think it's good too. I have a newsletter which goes out every single month and it's free. And there's about 10,000 people on it because it's really not that bad. There's lots of free content on there that I really that I hope you like and enjoy. And resources me. So I'm on all the platforms as SheX Purple. If you want to talk to me, I am very apparent and available. I'm always making free content and doing things like this. And this can be the start of a long-term relationship if you want it to be. And with that, I have a few treats for you. So I made a bunch of cheat sheets and they are gated. I will ask you to join my free newsletter to get them. So I know I'm pretty evil. But it's a React cheat sheet, a JavaScript cheat sheet, and a Vue.js cheat sheet. And no, I don't have a Python cheat sheet ready yet. And obviously I should if I'm giving this talk. But anyway, you just heard all the things that would be in the cheat sheet, so you already got this. And with that, I want to thank you so much. My presentation slides are available now if you want them, so you could just go grab them. And thank you so much to Extreme Python for having me. And I will see you next time. Thank you.